This is the Chapter 7 review worksheet, and I'm going to go over the problems on page 1. The first problem is integral of x e to the 2x dx. So this is a prime candidate to do the tabular method. So I'm going to use x as the derivative, and so take the derivative x and then 1, 0. And then for the integral, it's going to be e to the 2x. So the integral of that is 1/2 e to the 2x, and the integral of that is 1/4 e to the 2x. And so using the tabular method, you're going drawing arrows down the diagonal, and it's positive and negative, and you're just going to multiply the two together. So it's x over 2 times e to the 2x minus 1/4 e to the 2x, and since this is an indefinite integral, it would be a plus c. The next example is the natural log of x divided by x squared dx. This one you are not able to use the tabular method, and the reason is that you would have to call x squared, or you have to have a polynomial as the derivative, and you don't have a polynomial. So I'm going to use now the integration by parts, and so I'll use that acronym LIATE, and so I'll call u as the natural log of x, and then du is equal to 1 over x dx. So dv is equal to, and I'm going to write it as x to the negative 2, so that's easier to take the integral dx, and then v is equal to negative 1 over x. So then I'm using uv, so it's negative 1 over x, natural log of x, plus the integral of v and then du. And so if you multiply these two things together, then you end up with a 1 over x squared, which is x to the negative 2, and since it's a minus negative, it's a plus here. So your final answer here is negative 1 over x, natural log of x, and the integral of x to the negative 2 is negative 1 over x, and then it's a plus c. Okay, the third problem is x times the sine of 2x dx. So you can also use the tabular method on this. So you have the derivative to be x. So then if you keep taking the derivative, you have x, 1, 0. And then the integral on these would be sine of 2x. And the integral of that is negative 1/2 cosine of 2x. And the integral of that is negative 1/4 sine of 2x. So then you'd multiply, drawing your diagonals. So you have negative x over 2 cosine of 2x plus 1 over 4 sine of 2x plus c. Okay, problem number 4 is the inverse sine of 3x dx. So I'll use the integration by parts. So I'm going to let u equal inverse sine of 3x. So if you take that derivative, I have to use a chain rule. So it'll be 1 over the square root of 1 minus, and then it's going to be 3x quantity squared. So I just wrote that as 9x squared. And then the derivative of the inner is 3. For dv, it is dx, so then it's going to be v is equal to x. So this is your uv, so it's x times the inverse sine of 3x minus, and then it's v du. So that comes out to 3x divided by square root of 1 minus 9x squared dx. So for this integral, you need to do a u sub, and this comes out to a nice u sub if you make your radicand of 1 minus 9x squared as the u, because you have a x dx up in the numerator. So you have du is equal to negative 18x dx, and then I'm going to divide through by a negative 18. So on the left side, I have negative 118 du is equal to x dx. So x dx is going to work out nicely. And so I take the negative 1 over 18 and multiply it by the negative 3, which gives me a positive 1/6 out in front of the integral. And then you have u to the negative 1/2 power du. So then when I integrate that, you end up with u to the 1/2 power, and then I substituted the u back in and put in 1 minus 9x squared. and it's a 1/6, and then it's going to be divided by a half, which is multiplying by 2, which will give me a 1/3 out in front. So then the final answer is x inverse sine of 3x plus 1/3 square root of 1 minus 9x squared plus c. The last example for their last problem, number 5, is cosine cubed of x. So I'm going to break off one of the cosine of x and leave cosine squared x. Rewrite cosine squared x as 1 minus sine squared x using the Pythagorean identity. Then I'll distribute the cosine of x. So that gives me cosine x dx minus sine squared x cosine x dx. On this one, this is just the basic integral, and on this one, I'm going to do a u sub of u equaling sine of x, and du is equal to cosine of x dx. So then when I substitute that in, integral of cosine is sine of x, and then it's going to be u squared, integral u squared du, and that comes out to u cubed over 3, and I just substituted the sine back in. So your answer is sine x minus sine cubed x over 3 plus c.